So basically, I'm just going to cover nowadays like mostly underrated topic, I would say, in especially in the field of application security. So mostly like when we talk about the DOS attack, everyone is talking about the network layer only and taking the whole website down by bombarding with a lot of requests. But in this session, we are going to cover some logical attacks where we will not be bombarding with a lot of requests, but still we can turn down few of the features and features functionality and maybe the whole website. Okay, so starting with myself, I'm a security engineer at CultFit. Uh, we also we are a leading company in the fitness in India, and I do bug bounty hunting sometimes and part-time researcher as well. You can find my social handle at Abhi and blogs at this URL. So I'm just going to first show you the outline of this presentation, what we are going to cover, and the sequences. So again, I'm just going to show you the agenda of this today's session. So mostly we will be talking about the denial of services. It's type like incidental DOS attacks, which are not intended, but still we get our website down by doing some stuffs. Then we'll take the example of slash dot effect. Then we'll cover the malicious denial of service attack, which is like done intended by the attacker. And we'll talk about the previous research as well, like cache poisoning DOS attacks, in which we cover HTTP header oversize and then meta character, then method override, and some known application level DOS attack. And then we'll come to the main topic, that is logical DOS attacks and its case studies. Then we'll see the defense strategies. Okay, so we'll start with basics first, denial of service attack. As many of know, like Wikipedia or US CERT or any Indian CERT or whatever company or blog you will going to see, you will see one term that is turning down the machines or any network resource completely, just by flooding the target with a lot of request or lot of SYN packets. But if we'll see in the application security part, then it is a bit different. Like we do something logical with the application and then fall any features of that application that is not functional. So I just combined the above two definitions and created own definition here. Like if an attacker is able to stop legitimate users to use any intended functionality or feature of the application after or during this attack, should be considered as a denial of service attack. Okay, so firstly we'll talk about the incidental DOS attacks, which is example that has been created at during the 90s, which was like done on the on a website that was slash dot. So actually, not every denial of service attack is a malicious. Sometimes it is a byproduct of something else. So there was a website which was like collecting a lot of news from different sources and putting it on the main website. So if we follow some news and click on one link, then it is going to show you the main news. So that website was handling that slash dot. So one news was so popular that everyone started searching for that news and coming on the slash dot website, and then after clicking that, they will be redirected to another website. So that website was not that website was not configured to serve a lot of traffic, but still when a lot of users are started coming on that website got down. So that was totally unintentional. So that's also that I categorize into the incidental DOS attack. Different scenario is malicious denial of service attacks, where the attacker intentionally turned down the website with some kind of either bombarding with a lot of packets or doing some logical stuffs. Okay, but as you have seen that, how many of you guys are bug bounty hunters? Okay, one, two, yeah, few of them. So most of the times we see on the HackerOne or Bugcrowd platforms, it is always out of scope. Like you can see on the Baidu, it is out of scope vulnerability. On BlackRock or Booking.com, everywhere it is out of scope. So I'm just trying to bring attention and like make it into the scope so hunters can get more wide attack surface. Okay, so previously, few researchers have already present on the cache poisoning attack, where they have shown that how a cache server can be tricked to serve a lot of unintended data to the legit customers, uh, which should not be done. So in this example, just I'm just going to show you how it is working. So cache's main work is to like keep a copy of static data into their server, and when anyone trying to call that particular endpoint and there is no change in the data, then it will serve you directly. So in the first, you can see, let me use the pointer. So in the first box, we can see a client is requesting index.html with a malicious header with some kind of value. So it is requesting it to the main server. So it will first pass through the cache server, and it will keep a copy of it, copy of the response when it get from the main web server. So main web server will not serve such kind of request because it is containing the malicious header. So it will show you bad request, and that copy will stored in the cache server. So if any legit user is trying to access the same page in the box 5, you can see he is just trying to get the index.html page, but he will not go to the main server. It will directly be served from the cache server, and he will get the bad request. So it is also kind of DOS attacks, like many legit users services unavailable at the moment. So same thing is done with the header oversizing as well. Like few of the website, and like with the on the request header, we have a limitation of maximum size limit of any header value. So you can see attacker again has put a header that is oversized header 1, and it has some lot of bigger values, and then sending it to the main server. Again, the cache's main server will not respond, and it will store the error into the cache server, and cache server will start serving the error page to the legit user who is trying to get the same content. So you can see the example here. That was X request ID, where I have put a lot of strings character, and when I try to send it, then the server respond with the 431 status code, which is request header field is too large. So if the same thing is like in the same network, especially in the same region, if someone is trying to access cult.fit cities slash v2 endpoint, then they are going to get the same response. Then we got the meta character header. Again, the stuff is same. The main concept is same as a cache poisoning, but here the attacker is doing with a special character. Now he has put /n as a header value in the X meta character header. So again, he will get the wrong response, and legit user will try to access it, and he will not get the right response. Similarly, with the method override, here he is forcing the main server to use the post method while sending the request in the get method. So main server will not respond it as it was expecting get request, but again with the header, it understand that it is a post request. So it will send the 404 error that method not found, or maybe the method not implemented yet. So if any legit user is going to access the website at the same moment, so he will get the 404. So now we have seen a lot of known application level attack as well in the previous from the community application security community. That is email bomb attack, billion loaf attack, which is a part of XXE attack, where we take like we exploit the misconfiguration of XXE. Sorry, XXE. Yeah. So then we have a zip bomb attack. Then uploading a large file, like you can crash a server just by uploading a very large file. So it will start processing that file alone, and other user will not get respond on time. So now comes the main thing is logical DOS attacks. Why this is important, we are I'm just going to cover all these things with the example of these 5 case studies. First one is a long string DOS attack, which is very common. Then we'll see the complex calculation, then with the captcha and then password, then access control, how we can convert it into the DOS attack, which is still not out of scope, but few company provide a good bounty amount. So first case is long string DOS attack, where we can just put a lot length of string into any parameter. Like if you are serving a website which has a parameter days or something else, like anything can be there, or name field, or maybe the address field or something. You have to put a lot of character inside that particular parameter, and the site is going to process it and it will crash, unfortunately. The main example of this long string DOS attack, you can find it as at a password reset functionality. When we put a lot of character inside the password, then it first go to the server and then start the calculation of hashing it, or maybe the encryption sometimes they use. So it will take a lot of time to just process that particular string, and that will travel, like CPU users will be high for that server, and other users will also get impacted. Then comes the complex calculations, where generally we see in the e-commerce website, mainly quantity is multiplied with the how much is the price of one particular product. Let's suppose you are buying a product which is of 500 rupees, and then you select the quantity of 2, 3 or 4, then they will simply multiply the quantity with the price of single product. And let's suppose an attacker just intercepted the request and increasing the quantity or maybe the price. Sometimes, like most of the times, prices will be fixed, but still quantity can be vary, as it should be the dynamic. So what the attacker will do will simply just change the quantity and make it a large calculation for the server. So it will start, it will not respond as expected. So you can see the example just right here. Here the quantity is 1 and the price of product is 1149, and you can see the response time is 202 milliseconds. But now I am just going to change the quantity and see what the response I am getting. So here I have changed the quantity to 129, and it has multiplied 129 with 1149, and that will be done at the backend. So after getting the calculation done at the backend, we will get the response at the client end. And as you can see, compare the response time. Here it was 202 when the quantity was 1, and now it has become 431 when the quantity has 129. Now again I started testing with the larger quantity, and here I can see when I have increased a quantity amount to something else, something big variable, then the response time again becomes a very like lengthy. So here the response time is 1765 milliseconds. Similarly, when I increase it, the response time get increased as well. So if I'll do the same stuff with a lot of threads, so the website will start calculating at the backend, and again the CPU uses will be high as these calculations are very large. So it will impact the other legit user as well. They will not get the response on time. Okay, so what would be the remediation for such attacks? So one thing is to just put a input validation that will work in most of the cases, either it is a SQL injection or XSS, and in this case as well. Like input validation and limiting the maximum upper size of any product quantity. Like you cannot buy product more than 100 or more than 200 based on the requirements. So you can limit that quantity amount, then input validation should also be on the place. And then we should also place the rate limiting as well. That you cannot request, let's suppose you are using AWS, then there is a limit of minimum limit of 100 requests or per minute. So you cannot do that, and you can block the user if it is doing so. You can implement the same thing on the uh, backend code as well. Third one is improper CAPTCHA implementation. Okay, so here the scenario was something like they have put CAPTCHA just to protect the brute force attacks. Most of the time they do that, just like no one is trying a lot of password for a single user to protect the brute forcing that login page. So they were not using some kind of predefined or like Google CAPTCHA or maybe human CAPTCHA or something. They were using their in-house CAPTCHA tooling, and they have implemented their logic of their own. So here the scenario was something that if you request the login page, then first they will show the login page, then they will call another API, which was something similar to this one, redacted.com admin auth, then write data portal, and with there was a parameter that is t, and with associated with some value. So if we refresh that particular URL again, so CAPTCHA got refreshed and new CAPTCHA was assigned to it globally. So I'm just going to show you the example here. This was the page, and here there was three fields. One was email, then password, then verification code, CAPTCHA verification code. So this was the URL, I mean request, and I just started calling the same request again and again after 15 seconds of throttling. So it was requesting to the server to give me a new CAPTCHA in every 15 seconds, and latest CAPTCHA was valid for all the users who was using that portal. So basically, it created a denial of service kind of scenario where no one was able to log in, because whenever he was trying to log in, my script again requested a new CAPTCHA request, and that CAPTCHA was valid for the all users. So when I've given the correct CAPTCHA, it was showing that please enter valid verification code. Okay, so next one is improper password reset implementation. Okay, so here sometimes I'm with the whole these test cases. I just want to bring attention to that कि uh, we should aware with the business logic flaws. This is the main thing. Actually, in this particular case, improper password reset implementation, this could have been avoided if the architecture was correct. So here, what was happening? Uh, there was a website that is GetFitso. It comes under our company's scope as well. So there was a feature of resetting the password, which most of the website has if it has login or sign up pages. So while resetting the password, you have to enter the email and phone number, and the authentication code will be sent to your email address. So this was the request. When I sent with the email address and phone number, this was the success response. Now, if we send this request to the server, then you can only log in after resetting the password. That it won't allow you to use your older password if you somehow you remember it. So let's suppose the exploitation of this scenario would be something like ki, you find a lot of, let's suppose this page was having only email addresses as a password reset, like to get your password reset done, you need to enter the email address only, and I got a bunch of email addresses. So I'll just put a script to request for this, using this request, it will just send this particular API with the email address, taking one by one of them, whichever email address I have. So you won't be able to log in because you need to reset the password. And when the victim will try to again reset the password, again my script will send another request. So that will be again invalid. So this will again create a denial of service kind of scenario for those email addresses which I have access to. Not access to, I have get it. Okay, the last one is access control to denial of service attack. Uh, I has found in another bug bounty platform which was running. So actually in the bug bounty we try to chain the attacks to get a more impact and get a larger bounty. So here I found a case where I was using insecure direct object reference vulnerability and escalated it to denial of service attack, where I was able to create a scenario where no one was able to use a particular feature. Okay, firstly I'm going to show you how this website was working, then show you the demo how I have done the exploitation part. Okay, so this was something like WeTransfer. We might have used for transferring the files from one person to another person, maybe a friend or someone. So it was asking for a attachment that you have to drop it here, then email from and to whom you are sending and who is sending the email, and then there was a field of phone number. So if you enter all those, you will get a OTP on your phone number, and once you enter the OTP, you can share the file. So it will show you something response like that, file transferred successfully, and you will get the email, and like receiver will also get an email whatever attachment you have sent. So the problem was with the cross button here. You can see here, like if you accidentally uploaded a file which was not intended to upload, like let's suppose you have selected that wrong file, testfile.txt. So you need to click on the cross button to remove that file. And when I was clicking on that cross button, this request was being generated, which was some APIs remove share file, and it contains a file ID in the body, which is file ID equals to some ID. So I took it as it is using the file ID of this particular file. So whenever we upload a file, it will get a file ID for us. So I have sent it to the repeater as usual, and then trying to play with it just by changing the numbers. So earlier the file ID was 455, and when I send it to server, it gives me a response of success. So that means that file got deleted from the server. Okay, so now how did I achieve it to, like that was a kind of firstly IDOR attack, insecure direct object reference. Like I can change the file ID parameter and I can delete someone else's file from their own system. So okay, so now I try to escalate it to the DOS attack, so maybe I get a good bounty, and I got that. Okay, so I created a script dos poc.py. Maybe I have to click on that. Yeah. Okay, so this was a simple script which was doing nothing, but okay, this is the flow that a script has. First, you need to upload a file on that particular website, and you get a file ID in the response, or you can get the same file ID inside the source code as well. I will show you in the video. And with that file ID, you can just use it with that script and write it as a first argument. Like I have written here, Python dospoc.py and then file ID. And this script will create a range of 310 to 330, because I am using here 310. So I'm just given a range of 20 indexes, and then it will start sending the remove request to those file IDs from 310 to 330. And if any file ID is found to be valid and get a like success response, then it will automatically adjust from 310 to 311, and then again it will send those remove requests to from 311 to 331 file IDs. So when we start the script, it will look something like this. I'm showing you the video. So here, yeah, I'm just added a file and then trying to intercept the request. And I have just intercepted that remove parameter, I mean remove API call. And I got a file ID of 489. And let's see the response of this file ID. That was success. That means that file ID has been removed from that from the server. But okay. So again, when I uploaded it, I got a file ID in the response. I just wanted to show that. Now I started an attack. .492 is the current ID. All I was trying to get the current file ID, so I can create the range from that file ID to the next 20 indexes. And see, I have started that script, and when I click on share with giving the correct OTP, email address and OTP, here I have given. So it is showing something went wrong. Actually, the file got removed, but still the user is trying to share the file. So it is getting error, which is something went wrong. So I tried it 2 times, and the whole time the file got deleted from the server, and it was showing something went wrong. Okay, now coming to the like how it is dangerous, more dangerous than a normal DOS attacks. See, firstly, the normal DOS attack will be very easy to identify. You will get a lot of traffic from any particular single IP or any particular API call, or from the different source IPs on the particular endpoint or something. But these kind of attacks are more sophisticated because it is hard to debug or detect. Firstly, you won't know, like most of the user will be impacted that they are getting something went wrong. But if we'll come to the debugging part, it will be hard to detect like why they are getting this thing. And again, as we put the firewall in place to avoid attacks, application attacks. So we generally define certain rules to recognize this kind of signature, and then filter it based on the signature, like XSS or SQL injection. But there is no payload, malicious payload that we can put it as a rule in the firewall. And we can't even see a malicious behavior or pattern. And for such kind of scenario, we don't even prepare. Like maybe we can do some kind of like make use of certain web service, Amazon services, and create a anomaly detection. But we don't have pre-configured rule in place inside the firewall. And also, if we come to know about such scenarios, we can't even put a role by using the WAF independently to avoid such DOS attacks. Okay, so just going to cover the defense strategies. Firstly, it will be secure architecture of the application. At the time of building the application, first you need to see the whole flow of the application. As we have seen in the reset password scenario, that no, in the IDOR case, that could have been avoided if simply we put the uh, file, I mean, removal of file or adding a file after the verification, then that could have been avoided. So secure architecture is a bit compulsory. Then input validation always there, and in mathematical operation, as we have seen, we should put the lower bound and upper bound for all kind of parameters based on requirements. Rate limiting should be placed, but with some different logic, I would say. And regular security audit needs to be done for any kind of application which you are using inside your organization. And the last one will be anomaly detection. So this is the main thing which we should be taking care. With the Lambda function, Athena and WAF, AWS WAF, we can detect and block the anomalies based on your application. You have to analyze it first, then you can put a logic uh, based on that. So the first thing is rate limiting that everyone must have put on for their application. That if you are getting a lot of hit on a single API from a single source of IP, then there should be a rate limiting of 100 or maybe 200 requests, that they should not be able to perform any activity after like bombarding with 100 requests or something. Then there comes the second part where the attacker starts rotating their IP address. Then the problem again begins. So firstly, you need to keep the critical APIs after the authentication, as I say in the case 5, that if that application owner has put uploading a file or deleting a file after mobile number verification, this could have been avoided, cause any user who is authorized for that particular file should be able to remove that file. So no one could have able to remove the file of other. So first you need to keep the critical APIs after authentication, and then second one will be uh, if a single session token is being used from more than 5 or 10 IPs with a specific time, then destroy the user session or block the user. So let's suppose for a single user, uh, the request is coming from the 5 or 10 different IP address, as we have taken a prerequisite of attacker has already rotating their IP address. So if same session ID is being used from the 5 or 10 different IP addresses, so they will get blocked just by analyzing through the whole that function we have created, Lambda function. So how we can achieve that is simply just by putting firewall, and we can store all the logs into a S3 bucket, and then we can query and parse the data from that S3 bucket, whatever the request we are getting, and write a Lambda function that if a particular API is being called from the 5 or 10 different source IP addresses, then a block function will be triggered, which we can simply use the boto3 module, Python module, and directly block that particular IP to the firewall. Then we can just block such cases. So that was all from my end.
I think one of the biggest challenge here is that we do have a lot of security testing or even QA testing, but generally they look for things like logical errors and cross-site scripting and all that kind of stuff. But something like this is a bit more sort of difficult to
Yeah.
achieve because it is a mix of both the logical and the security implications that come out of it as well. What advice can you give? Where do you think this particular um, function or testing, where should it sit? Because as you mentioned, right, there are a lot of providers out there that just wouldn't do denial of service attack
Yeah.
sort of testing. So what would be one practical thing, I guess, that everyone can actually take home from here?
Okay, see, as we all know, security is everyone's responsibility. So it starts from the developers who is developing the application. Firstly, they need to do the secure coding, like input validation, all those things can be covered in the development part. Then before that, even securing secure architecture is also like a key factor to avoid such attacks. As if we have implemented a correct flow of business logic, then it can be avoided, as we have seen in the case third and fifth. And later on, we somehow we need to rely on the firewall as well. So to uh, to make it more precise of that particular any firewall, you need to do a parsing based on your requirements, so your as per your business logic. So let's suppose there is any page, I mean any website which is using coupon code. So on that coupon code, multiple users will try to, I mean multiple attackers will try to get a correct coupon code. So first thing is, basic thing is just to put a rate limit that you cannot try more than 100 coupons from single source IP. But if you'll what if an attacker starts rotating their IP address? Then again, it will be a big trouble for web application firewall to determine whether it's a legit. Different users are trying a different coupon codes, or it's the same user who is using a bunch of API gateways IPs and then trying to attack the system. So to avoid such kind of scenario, we need to use Lambda functions, and we need to parse whatever the logs WAF is already collecting into the S3 bucket, and then we can avoid. Yeah.
A little something.